As I always say, for those of you that are maybe on a different problem, you're still welcome to hop on board, come along for the ride. This, you said 17, Stesha? So it looks like first off, what kind of problem is this, Stesha? Hold on a second. You're still not answering this question correctly. What kind of question is this? I keep saying this because I want to get this stuck in your head. When I ask the question, what kind of problem is this? Listen, I don't mean to be weird, but your answer really at this point should be, I'm not sure. And listen, I agree, like it's probably going to shake out to be that. But at this point, I'm trying to get into your head the idea that we don't yet know what we're up against. Why? Why don't we know for sure? Because there's a GCF. And remember, the problems that I want you to do are going to be hidden underneath greatest common factors. And so you've got to get them out. And so, yeah, I'm with you, Case. And it's obviously going to be one of those, but let's try to train ourselves to think we're not ready to answer that question yet. We have to take all three terms and divide them by what? 7x, right? And so all three terms can be divided by 7. And all three terms have an x to offer up, at least one. So we're going to pull that out. And then we'll be able to talk about what kind of problem is this. What's left of the first term if you pull that out? Nice. Second term? Yep, minus. It's a 48. So far, so good. Okay, so now we can see the white problem is the actual math problem. And yeah, like Kason said, it's definitely a lookalike, right? So we're going to leave our GCF out front. And then we're going to, with lookalikes, you just want to treat it. There's a reason they call it quadratic form. You treat it just like a quadratic. It flows just like a quadratic, but the exponents are just buffed. So what goes in my shells? Nice. So we divvy halvesies. What am I?
Plus and minus.
Easy for you to say, huh? So we need one of each. And then we're looking, I think it's pretty obvious that we're looking at a 6 and an 8. Right. Good job. So at this point, is this what this quiz is all? I mean, quiz step 1, GCF, step 2, know your opponent. And then step 3 is just keep being persistent and vigilant and say, like, am I done? Am I done? Am I done? And are we done? What's that? We are not. So I would say that 7x is done. And I would say that x cubed minus 6 is done. X cubed minus 6 is trying to be, he's like a wannabe difference of cubes, but the 6 ruins it because 6 is not a cube. However, x cubed plus 8 is a, what do we call that? Say it. There is no such thing as a sum of, I mean, there is, but we can't factor it. It is a sum of cubes.
Oh.
And so we recognize that x cubed is a cube and 8 is a cube because it's 2 cubed. And remember that with cubes, you can do plus or minus. Squares are feisty. Squares are, you got to have a minus to do squares, but cubes go both ways. So I recognize that. And now I know I've got a brand new little problem on my hand. So as it pertains to this little purple thing that I've underlined, we got to go A, B, short set, long set. What is the A value there? It's X. And what's B? Good. So the answer at this point is going to wind up, what I like to do is put it's just a matter of preference. I like to put all my dead factors first. So like I'm going to take the 7x and just copy it down. And I'm also going to take that dead wannabe difference of cubes and I'm going to copy it down. Just get the dead ones out of the way. But then that purple one is the one that's going to break short set, long set. So what is short set going to be, Stesha?
Oh,
Nice.
and then X squared. Plus zero.
No, it's got to be minus, kid. Remember that if you don't use the minus in the first, then you have to put it pretty quickly in the second. So minus 2x.
And then X squared.
Plus 4. Your cube formulas will only ever have one minus in them. And it's simply a matter of memorizing, will it go in the short set or will it go in the middle of the long set? It will only go in one of two places. So that should help you when you're going through the signs. And I think I said this yesterday, but with, getting older and teaching multiple of the same thing, I sometimes forget what classes I say what to. I think I said this yesterday. The long set will never be factorable. Did I say that? Okay. So that's something you're going to want to take with you because you could waste some time wondering, can I factor that down? Is that a quadratic trinomial that I can break into shells? And the answer is no. Tomorrow it'll be no. 20 years from now, it'll be no. Like long sets from cubes are not factorable themselves. It's all done there, Steidemann. Get it? All right. Pausing recording.
But I can hear John understand. You can get it, you can hear John understand. Yeah.
So the question is, what kind of problem is this? The answer is, I don't know yet. I'm going to try to just train that into you like a robotic response. And why don't we know yet? All right, so there's a GCF that's coding or covering what I want you to see. So what are we going to pull out? For sure, but there's two more things actually that we can pull out. Yes, we can pull an X, I agree. I agree with that. And there's one more thing that we need to pull out. Correct. And so I won't be there on Tuesday to like guide you. So you need to go through like a robot and say, first off, does it start with a negative? And if it does, start with the negative. And then but you got to structure yourself through that without my help. So we need a negative. I agree we need a 3, and I agree we need an X. All three of those together form the GCF. So we're going to pull out the negative and the 3 and the X. And then we will unearth the actual math problem. So what's going to be left of that first term? 16x squared. Yes. Remember that however many x's you pull out, you drop all your exponents by that much. So if we only pulled 1, we drop 1. And then how about the plus 27x? What's that become? Mhm. Now, what kind of problem is it? Good job. Good job. That's how quick that needs to be. Well done. And so once we recognize our opponent, then we have to have a strategy. And do you know how to factor that difference of squares? Plus 3 and a minus 3, right? And then what else?
So we don't expect to lost X to the one X to the we don't take the person that make sure everything's.
So I'm going to show you a trick, okay? And if you don't like my trick, then I'll try something else. But if you're struggling with these, the way I think of a difference of squares is I say, what's the square root of this? And when I say that, I mean, like you got to square root both parts. What's the square root of 16? Right? And what's the square root of x squared? Just x. And so I have a 4x. It's kind of like AB, short set, long set. Like knowing these, I don't write them down. Like, but you should, if it helps, do it. And then what's the square root of 9? Right, now what you're gonna do is use those two green things and just build a plus and a minus out of those. You got that? Done. And because they don't have exponents anymore, because they're linear factors, then we know that we're done. Like, there's never gonna be more meat on the bone if you're working with a linear factor. Like, it's stripped of everything that it possibly had, right? Does that make sense? Yeah.
The short one in the long side? Yes. Yeah. You just leave -6. What? -5? Negative. One, yeah, I'll show you. Yeah. Plus, right? And then
I was like, I don't know what to do, so I'm moving on to number 2.
I will tell you this, first of all, if something only has two terms, then you should know right away that it's one of three things. Do you know what I mean by that? There are, I think, I want to say maybe we've learned like 5 categories of problems. I think it's 5. So we've learned quadratic trinomials. We've learned lookalikes. We've learned grouping. We've learned difference of squares. We've learned difference of cubes. And we've learned sum of cubes. And I think, unless I'm missing something, that's all. And I said 5. I mean, that's technically 5 things because I think sums and differences of cubes are kind of the same. Like, we use the same formula for those. But these are the flavors of problems. And so you ask the $1 million question, how do I know what it is? Well, a quadratic trinomial is going to have 3 terms. The prefix tri implies 3. So if I see something with 2 terms, so let's say I gave you a problem like, 27x cubed minus 343. You could right now up here on the board, you could rule out 3 of these right now. Which 3 could that not be?
Probably.
Yeah, I mean, no, probably. You need to be sure. It cannot be a trinomial. It's literally a binomial. So it can't be that. What else can't it be? Right, because lookalikes are just like quadratic trinomials. They have 3 terms also. They just have buffed exponents. What else can't it be? Right, and why do we know what is grouping? What's our tell for grouping? Groupings have 4 terms. If I want you to do a grouping problem, it's going to be a long one, like problem 10 or 15 or 30 or 25. Do you see how those all have 4 separate terms?
Yeah.
I need you to know that if it's got 4 terms, that's the easiest one, I think, to spot. If it's got 4 terms, you are targeted right in. You say this is a grouping problem. The other ones, we got to do a little bit more detective work. So with this problem that I wrote on the board, we can rule out trinomials, lookalikes, grouping, and now we're down to it's either squares or cubes. And that, you got to know. It's a difference of cubes. We know for sure it's not a difference of squares, right? The exponent gives that away. The 27, the 343, none of them are squares. So good job. So once we identify what it is, that's when we go and say, okay, I'm ready to go because I know. And that is job 1, is to identify your opponent. And I said this weeks ago that this day would come where factoring gets harder when we're not just practicing the same skill all day. Cubes are easy when we just do a whole worksheet of cubes, right? But when you got to pick it out, that's the money step. How about you should. How about let's talk about this one, Kyla. What can this literally not be? There are 4 things on the board, just straight up, that I can just kill. What could it not be? None of the cubes and not a difference of squares. A difference of squares has two terms, just like the cubes. Cubes and squares often get confused. You got to know what's a square and what's a cube so that you can tell the difference. The short problems with two terms are in those bottom ones, but it's not squares. So it's either a trinomial, quadratic trinomial, or a lookalike. Which one is it?
I think we just started things.
It's a lookalike because the exponents go 4, 2, 0. If it's a quadratic trinomial, the exponents are going to go 2, 1, 0. Do you see? You sure? I'm not sure I bought that. Or does that, if I wanted you to do a quadratic trinomial, like an old algebra 1 problem, I would have written the problem like this. I would have said x squared plus 2x minus 24. You see, by just pouncing down the exponents a little bit, down to 2, 1, and 0, now I've made it a quadratic. Quadratics have a power of 2. Lookalikes are structured like quadratics, but the exponents are all doubled. Do you see exponents go in a pattern like 6, 3, 0, 4, 2, 0, 8, 4, 0? It's a lookalike. I mean, they're all going to go bigger to small, but if they go in a particular pattern of, if this is a quadratic, just for the record, if I wanted it to be a lookalike, then I would have made it like x to the 10th plus 2x to the half of 10 minus 24. That is now a lookalike. Okay. So job 1 is the categorization and say, what am I up against? You saw, what's your question?
I figured out, but I think you just got us started on the second question and then we had a. Yes.
So you're good?
Yeah, I'm good now.
All right.
Yes.
What's up?
Yeah.
She explained.
Yeah.
What is this? What kind of question is this? Thank you. Good. I will say this, if I scroll back up to what Kyla and I were talking about, you right now can say for sure that it's not one of these, and it's not one of these, and it's not one of these. Anytime you see just two terms like your question, then I know it's either a difference of squares or something with cubes. You get that? Okay, so let's figure out what it is, and how are we going to figure it out? Pull out the GCF. And what is the GCF? Yes. And what does that leave behind? Now it's go time. And this again goes back to Kyla's question. And this, I'm really glad that she asked it. It's about time, because this is the money question. What is it? Yeah, you're asking me that, but you should say it with, put your foot down and say it is a difference of, we know it's not a difference of squares. Like the exponent of 3 out, 8's not a square, 20, it's trash. So, but it is cubes. And so when we do cubes, like I did with you last time on squares, the key is to know, like, remember on that last one, how we found the 4x and the 3, and then we just built little things out of them? That's what you do with cubes. You just find your little guys, and then you plug them into that long set or short set, long set. What is A going to be for this? Yes. And again, just like we did with squares, we have to, so really what it winds up being is we take the cube root of 8x cubed, and that is, like you said, good job, 2x. Without these A and B pieces, just sink like a stone. You got to have those guys. And then what is B? Good job. And the problem is now effectively over, except for the robot part. Like, that wasn't robot. That was you in your brain figuring out a GCF, cube rooting some things, but now it's robot mode. And the robot, like, I could program my graphing calculator to do this from here, I just take my GCF and put it in front. I build a short set and I build a long set. And the things that go there, there's no more speculation. It is prescribed, right? What goes in the short set? 2x minus 3. And remember, please, that the short set will always mimic the sign that you had to start. Okay, so the short set's going to be 2x minus 3. And now the good news is you've used your minus, so it's all pluses for the rest of the way. So what's our first long set term going to be? It is 4x squared. You got to square both parts of a, the 2 and the x. So you get 4x squared. Middle term.
Yeah.
And this is where your notes will help you so much. And I know you've got still 4 or 5 days to still prepare notes, but with that formula there, you'll see the next thing is just to multiply A and B. So plus AB. Done. And then the last part, B squared. Done. We know we're done because the long set will never be factorable, and the short set is a linear factor. It doesn't have any x squareds or anything, so stick a box around it. It's done. Make sense? Nice. Questions? Stesha and Irene. Styrene. Russia. Who's... You can't stop me.
Very necessary.
Good God, you a little salty? Who's, I don't know who's less. I was going to pick on the less salty one first, but you're both salty.
Okay, 19.
19, you betcha.
Okay, right?
What kind of problem is number 19? God, I love that you said that with such passion. Thank you. I was having this conversation with Kyla a minute ago about how do we classify it. We could look at this right now and say it's not a quadratic trinomial, it's not a lookalike, and it's not grouping, right? So we can at least, we know it's either squares or cubes. We just got to go figure it out. So how are we going to get there?
Down to, so you can just split it up.
Tiene que dividir los dos números por 3. 81 dividido por 3 es 27. Right. And you know, that's what calculators are obviously welcome at this point in our lives. Like 81 divided by 3 and 192 divided by 3, those are outside comfort zone, right? So you just kind of, you screw around a little bit until you figure it out. And you kind of know that you've hit the right thing when the numbers that you're going to see strike a chord. If they don't, you just haven't been paying attention for 2 weeks. I mean, like 27 is jackpot, that's a cube. And then 192 divided by 3 is 64, jackpot, that's a cube. So when nice numbers pop themselves out, that's usually a pretty good sign. So, well, there you go. Cat's out of the bag. It's a difference of cubes. So what is A? 3x to the 15 divided by 3. Nice job. Remember that when cube rooting, we actually just divide exponents by 3. It's pretty slick. And what's B? And hey, we got our guys. Like now it's just a matter of short set, long set, plug all your stuff in and then see what happens. So we're going to leave the GCF out front. We're going to build shorty, longy. What's going to go in shorty? Nice. Long set? Nope. It would be 9, but it would be x to the 10th. Yeah, and that's interesting how exponents like have their own set of rules. Like you're not actually squaring the 5, but since you're squaring x to the 5, we know from the old exponent properties that we actually just times 2 plus plus. Good. Now, this is not, I just did one of these a minute ago and I was able to just look at it. Like this is the one that Alicia and I did together. And we were able to look at this one and just know that it was dead, really, because we know GCF is dead. We know long set's dead. And this one was linear. So we were able to quickly say it's dead. There's a little bit potentially more meat on this bone because like we know 3's dead. Duh. We know long set's dead. But this one has a little bit of life, right? Like it makes us take pause. But I hope we agree that it's dead. I just was going to say, like, you need. Maybe I shouldn't have been so long-winded about that. The point is, like, you need to pay attention to short set because if there's going to be more meat on the bone, it's going to be right there. Like that tried to be like a difference of squares or something, right? It just failed. So you're done.
Can I do this one? I'll be right back.
Yeah.
Okay.
Hi. Of course.
That's right.
So I am. I'm just going to work number 6. Would you like some assistance? This one's not going to take long. There's a tiny little bit of meat on the bone. What is this? What's the GCF? Nope. In order for that to be true, they'd all have to have X's, and that one doesn't. So what's the GCF? Yes. And what is my polynomial going to become when I chop 3's? Now we can see clearly that it's a quadratic trinomial, right? And so this is just old school. This is just GCF, build your shells, put your X's, put your pluses, put your 1's, done. Easy peasy. Okay. And if you wanted to, you could write this as 3 times x plus 1 squared, just because those are exactly the same. You don't have to, but it's more mathy, but you don't have to. J-Bull, what's your question? Oh, okay. Well, if you decide after this that you need help, let me know. All right. Irene, a while ago I answered Stesha's question. Do you still have a question? Which problem? 23. What is it? Etiquette. Yes, you may go to the bathroom, sure. Absolutely. Go fill up a water bottle, go to the bathroom. You bet.
No, yeah.
No way.
We take me there and then stop. 9, 3. No, you can use 9. Yeah, or 9.
Yes.
Okay.
Then we rebuild.
9. Yes.
Yes. Sorry, my there it is. I know exponents are little boogers. When we pull stuff out, it's also convoluted and mixed together. When we pull stuff out, we subtract exponents. When we root, we divide exponents.
Because I was right, but I didn't think negative. I just did negative. I just did negative. Which I should have done.
Yeah. That G in GCF is pretty important. And then the sign's going to change to minus. And then when you pull all that down, divide by 4, 64. What is that?
So that becomes X, and that becomes two.
Maybe, but in the things.
I don't know what just happened, but hold on, you didn't answer my question. Let me ask it again. What is that?
Oh. So that, a difference in-
Yes, it's also a difference of squares.
Yeah.
Hey, I need you all to stop what you're doing. Oi. Alicia. Hugo. Emmy, everybody. Okay, good. Listen. We have a situation on the board where you're faced with two possibilities. That thing that I have circled in purple is a difference of cubes, but it's also a difference of squares. And I'm going to tell you something right now, and I need you to follow these directions. You should put this in your notes. If/when you're faced with one of these that could go either way, pick the squares. You're going to get more meat off the bone this way. If you do cubes, you wind up being able to get to the final answer, but one of the things that you have to factor in the end is a nightmare. So I see some of you writing that down. I appreciate that. If you're faced with a situation where it could be cubes or it could be squares, it's a pretty rare situation. Pick the squares. We clear? So when we look at x to the 6th minus 64, we say, what is it? We go, it's a difference of squares. And yeah, I know it's something else too. Pick the better one. Squares will make it easier to pick the meat off the bone. I promise. Are you with me? Okay, back to it then. So we're going to see this as a difference of squares. Got it? So having said that, what's the square root of x to the 6th? Correct. And what's the square root of 64? Good. And you'll see in a second why I'm bossy about this. When you see what it creates, you'll see how easy it is to get all the goods out. So we're going to bring down our GCF of negative 4x to the 3rd. And then we're going to build our just a simple difference of squares, x cubed plus 8, x cubed minus 8. That's, remember, difference of squares is just square root plus square root minus square root. Are you with me so far? What do you see? And cubes can go either way. Very good. So that's why I say in a problem like this, to get that low-hanging fruit to appear, you need to pick the squares. It's so much harder to unearth the final answer from cubes. I'm not even sure, quite frankly, that it's something I'd want to try. So you're going to wind up with negative 4x cubed times short set times long set times short set times long set. Which one are you doing first? Okay, so we're doing the sum, which means that our first one has to be x plus 2. Remember that your short set will mimic whichever one you're factoring. What will our long set be? Okay, now I'm going to change colors here. We're going green. Now we're doing green guy. What's the short set? Nailed it. Great question. That's a toughie. Well played. We have 1 minute and 46 seconds on the nose. Tomorrow, we will continue exactly what we're doing. Monday, we will continue what we're doing. I will remind you, if you're sitting here today not asking questions, I sure hope it's for the right reasons. You have your own personal assistant over there. Hey, it was good to see you. Do you have